All right. Good afternoon, everyone, and thanks for joining today. This is Arif Rafiq, and we have a fantastic webinar lined up for you. It is about logistics, of course, so our title, as you can see, is From A to Beyond, Routing Optimization for Delivery Services of All Sizes. Your presenters today are myself, Arif Rafiq, and Brandon Wheatley, who is going to introduce himself, and I'm going to introduce myself in a little bit. But I also want to make sure that those of you who are listening can hear my voice. So the audio broadcast is available through your computer, or you can call toll-free. The number is at the bottom of the screen right now, and of course the access code is written there as well. Once you've connected to the audio, we will have question and answers available throughout the session. So if you do need to, just please click on the QA panel and make sure that you choose Ask Panelist. Click the send button, and we'll receive it. Now, we may not respond right away. Do not fret. We'll have your questions, and if we don't respond right away, we'll make sure that we get to the questions by the end of the presentation. But we do encourage involvement, so please do go ahead, and if you have questions, go right ahead and send them. So because we got an action-packed hour ahead of us, I'm going to just right away get started. So my name is Arif Rafiq. I am the Transportation Industry Specialist here with Esri Canada, and I'll be your co-host today. And joining me is Brandon Wheatley. I'll let him introduce himself.
Hello, everyone. Thanks for joining us today. My name is Brandon Wheatley. I'm a GIS analyst with the Community Maps program. And I just want to let you know that one of our goals today is we're going to try and show as much of this demo live as possible. That way you're able to see all the steps and you get to witness the processing power of ArcGIS Pro.
So just a few prerequisites. Just as you're going to be watching this demonstration, like Brandon said, we're going to do this live. So I wanted to list out some of the prerequisites if you want to follow along, if you're brave enough to do that. You're going to need ArcGIS Pro to actually work through some of this content. The other thing that you're going to need is Network Analyst Extension. If you're not familiar with that, please do ask the question. We'll definitely share some more information with you. And the final thing that you're going to need to do some route optimization is a network data set. And basically what that means is that's the street network, the underlying street network where we're actually going to build the optimization on. Now you have a choice here. You can either build yourself. The ArcGIS tool set gives you the opportunity to build your own network data set. But mind you, it is quite complicated to do that. So there are third-party sets available that you can purchase for use on your basically on-premise, and that gives you all the traffic, up-to-date live traffic, historical traffic. It also gives you things like turn restrictions and weight restrictions and axle restrictions and where you can drive a truck, all that fun stuff that you need to do some real route optimization. Or the alternative is you use the ArcGIS Online services. There's logistics web service that you can hit on, and you don't need to actually buy anything. You just use that. Of course, it consumes credits to use this service, but it is there for you. So just to make sure that you all know a lot of this is available, and we're going to show you how it works. So Brandon, take it away.
Awesome. Thanks, Arif. All right. If you guys are good to go here, let's jump right in. So in our scenario today, we have a small business that specializes in fresh, all-natural, organic donut glaze. And our headquarters hub is located in Sorel-Tracy, the star here on the map. And we have two customers, which are our coffee cups, one in Sorel-Tracy and one located in Montreal. Now, because our donut glaze is fresh and made daily, we need to deliver the glaze to our customers every day before their stores open. So our first question is, what is our delivery route going to be? And to figure that out, we're going to utilize the Network Analyst extension in ArcGIS Pro. So as Arif mentioned, first thing we're going to do is we're going to set our network data source. So today we're going to be using the Street Map Premium routing layer here. All right. And now we're going to go ahead and we're going to create our route. So the first thing that we're going to do is we're going to import our hubs. So the first stop of our trip today is going to be, we're going to start from our warehouse. So let's go ahead and import our warehouse here. And we'll run this. All right, so now you can see on the map we have number 1 and our warehouse hub. So that's going to be our starting location. And the next thing we're going to do is import our first 2 stops. So we'll go ahead and import our customer locations. And we're going to run this. And what we should see here is our stop number 2 and 3 are now present on the map. That looks great. And now the last thing we're going to do is we're going to import our warehouse hub again, because once we're done our deliveries, we'd like to return to the warehouse at the end of the day. So we're going to come here again, and we're going to import our hub location and run. Perfect. So you can see now that the 1 there has changed to a 4. So now that's overlapping, so that's both our first and last stop. So now it looks like we're good to run this tool. Let's go. All right, and look at that. So now we have our route, and we can see the total time of the trip is 138 minutes. We're going to be traveling 168 kilometers. And a nice little feature as well here in the top panel, if we come up, we have a directions, which opens up the directions pane here, which gives us turn-by-turn directions for the entire trip. And as you hover over each navigational instruction, you can see the little red dot there along the route. And I'm going to pass it over to Arif to give you the next section.
Thanks, Brendan. So let me just share my screen quickly here. Perfect. So we got our route displayed in front of us that allows us to get from our hub to our first stop in Sorel Tracy and then down to Montreal to make that delivery. Now, as you can see, all we really did was we asked for some directions on that route, and it gave us the information that we needed. Let's add a few more elements of reality into here, right? So we're delivering to coffee shops, which actually have a certain time that they open and a certain time that they close. So what I'm going to do now is I'm actually going to add some constraints to this analysis, and I'm going to add a time window constraint. So the way I'm going to do that is I'm actually going to use the attribute editor here, and I've pre-selected stop number 2 here on the map. That's why it's highlighted in blue. And there are 2 fields here called time window start and time window end. And that allows me to stipulate when this location is open. In other words, I can't arrive at that location if it's closed. I can't make a delivery. So I want to make sure that we provide enough information so that our route is accurate. So this location in Sorel Tracy, we're doing our analysis on the Monday of this week, so it'll be April 23rd. This location in Sorel Tracy opens up at 6:30. So let's just set this little guy over here. You can use this fancy time slider here, or you can just, type in as you wish right over here. Let me just do that so we can show you how it works. We'll just type in April 23rd, 2018, and we need to make sure we deliver our product before 7:30 for that location. And I'm going to do the same with the Montreal location. So let's click on stop number 3, and we'll do the same thing. So I'm going to add in some information here about the opening. Now, this is an urban center, so they open a bit earlier than the Sorel Tracy. This one actually opens up at 6 a.m. And let me make sure we put the time here, the date, so April 23rd, 2018, closing at 7, or we have to deliver by 7:30. So this one we have about a 90-minute delivery window, whereas the second one, for Sorel Tracy, we only have an hour delivery window. So I'm just going to make those changes, save those edits, and then I'm going to run this analysis again. That's all I've changed is I've added those time restrictions. So let's run the analysis and see what happens. Look at that. We got something. All right. Interesting. Something very interesting has shown up here, hasn't it? You can see that we're making our first stop over here, stop number 1 at 6:26. And stop number 1, remember, is the hub. That's the origin hub. So this means that we have to depart that hub at 6:26 in the morning. We arrive at stop 2, which is our first customer in Sorel Tracy, at 6:30, which is great because that's the opening time window. That's when the first time we can actually deliver that product. Then we make our trek down to Montreal, and oh, look at this. We get there at 7:37, which is about 8 minutes after the deadline that we've set. We stipulated that it has to be there before 7:30, so it shows up as an 8-minute violation. And then we return back to our depot and get back by 8:44. So this is obviously a problem, right? We can't get there in time to make that. But is there an alternative? Is there something else we can do? How about we ask the solver to give us an answer to that? Back to you, Brendan.
Thanks, Arif. Let's see what we can do here, see if we can make sure we can make this trip on time. So back into our Network Analyst route tool here, and we're going to come up to the sequence drop-down option. And you see we have a few choices here. We have a find best, a preserve first and last, preserve first and preserve last. So what we need to do here is we want this to determine the best route possible, but we need to make sure that our warehouse is our first and last stop of the day. So that's what we're going to choose here, preserve first and last stop. We're going to keep all the other settings here the same, and we're going to run this now and see if this can fix our violation issue. All right, look at that. Our violation is no longer there. But you'll notice that the sequence of our stops has also changed. Instead of stopping in Sorel-Tracy first, we're making the trip all the way down to Montreal, making that our first stop, and then coming all the way back up to Sorel-Tracy to deliver, and then returning to our warehouse at the end of the day, making all the stops within the deadline time for a total of 139 minutes and the same 167 kilometers. Awesome.
Thanks, Brandon. All right, so that was a success. We managed to make our delivery on time. Whoops, that's not what we wanted to show. We managed to make our delivery on time, and we had a success. So our donut glaze has actually struck a chord with people outside of Montreal as well. And a national chain has now decided to take up our donut glaze. This is a massive success for this small business, and so as a result, we went from 2 customers, one in Sorel-Tracy and one in Montreal, to the requirement of delivering all over the province of Quebec. So let me open up our new customers that we have here. And we can see we got a whole lot more customers that we got to deliver to. This is fantastic news. Well, it could be fantastic news, but it's also the moment that most businesses start having heart attacks and wondering how we can actually do this sort of thing, right? So nonetheless, it's an exciting point, but we now have to figure out, okay, of all the customers that we have here across the province, remember, we're delivering this all-natural donut glaze, so we have to deliver this daily to each and every one of these customers. The count is 540. That's 540 customers we have in the province of Quebec that we got to deliver this to every single day. So the questions that we have to ask ourselves now, A, can we do this? Are we going to be able to make these deliveries daily? Secondly, if we can do it, how do we do it? What is our deployment strategy to actually make this happen? And finally, what's it going to cost us to make this thing a success? So the first thing that you've seen me do is I've put in our new customers, and you can see them across the map here. It's about 540 of them. So what I want to do is I'm going to use another network analyst tool to help us answer some of those questions. So if I open up the service, oh, sorry, not that. I didn't want to do that. So my mistake. If I go to the Network Analyst tool, the one I wanted to show you is this service area. I want to get a visual indication of how far I can actually get to using the vehicles that I have at my one hub in Sorel-Tracy. So by clicking on this service area, I've been able to generate this little option here on my table of contents that gives me the ability to generate a service area. So it has a few options up here, just like you saw in the route option, but there's a couple of other things as well. A, we want to make sure we're talking about trucking time. I want to drive away from my facilities, and this here is a key variable. It's the cutoffs. In other words, how far can I travel from that from my facility in the amount of time that I've given it. And the amount of time that I've given it here is in minutes. So those are 2-hour segments, 120 minutes, 240 minutes, and 360 minutes. Why did we choose that? Well, remember, we're driving trucks away from our depot, and 360 minutes is 6 hours. So, I mean, that's a full day, assuming we want to get our drivers back to the depot at the end of the day. That's 12 hours of driving, and we don't want our drivers going any more than that. What we really want is we want our drivers to be at about this level, 240 minutes. That's an 8-hour day, which is reasonable for our drivers. So that's why I'd make sure I put these cutoffs in. The other thing that we have the ability to do is set some preferences here in terms of what we want these things to look like. And I've set up polygons. We can do a few different options here. I've put it on a high precision, just so you know it takes a different amount of time to generate these kind of results. If you go to the generalized one, it takes like seconds to actually generate the result you're about to see, but it doesn't really look that good. So you might want to choose standard precision or high precision. And for this particular model, I couldn't find a difference between the two, but in terms of time, the standard precision takes, I don't know, on my little laptop here, it's an i7 laptop, you know, it took just under a minute, whereas the high precision took almost 8 minutes to run. So it's a very heavy processing requirement here. But nonetheless, to save you from the time, we've actually pre-cooked it, and I'm just going to show it to you. So there it is. And what this is telling us is within that lighter green shade, we can reach all of those customers within 120 minutes, 240 minutes in the middle green, and 360 minutes in the darker green. It also identifies that there's a number of customers that we simply cannot reach in a single day's worth of driving. So we're going to need to do some alternative analysis here. We cannot do it with a single depot at Sorrel Tracy. We have to expand our business a little bit in order to make this happen. So off to Brendan to show you how we're going to expand.
Awesome. Thanks, RF. Let me just share my screen with you guys here. Perfect. So now that we know we need additional hubs, we have to ask ourselves, where do we put them, and how many of them do we need? So looking at our customer locations here, we've gone out and assessed 14 potential new hub locations, and you can see them on the map there. They're located around where a lot of our customers are. So let's now figure out how many of these we need and which ones. So again, we're going to come back to our Network Analyst extension, and this time we're going to utilize the Location Allocation tool. This guy here. All right. So we have a few options up here, similar to the other tools as well. The first thing that we're going to do here is we're going to now import these 14 new facilities into the tool. So let's go ahead and do that. All right, and for the sake of time, I've gone ahead and imported the customers as already, because there's about 540 of them. It takes a couple of minutes, but I figured, let's do that ahead of time and just be ready. So there we go. So now we've got our customers imported. We've got our hubs. The last thing we need to do here before we run this tool is we need to come into Attribute Table and make a quick edit. Because as of right now, all of our potential hubs here are all considered candidates. However, the location in Sorrel Tracy, we already have a hub established, and we want to keep that hub there. So we're going to change that to a required hub. So that way, it's going to guarantee that that's going to be one of our chosen hubs. And then we're going to come up and save that edit. And come back to our, save this edit. All right, perfect. So now we're going to come up here to the top and see what kind of options we have. So in the type here, it gives us a bunch of choices as to what type of location allocation we'd like to choose. So the first one we're going to run here is called Maximize Coverage and Minimize Facilities. And what this is going to do is it's essentially going to tell us the minimum number of hubs that we need to deliver to all of these customers in one day. So now that that's good to go, let's run this. This should just take a minute here. All right, awesome. Let's see what we've got. So taking a look at the data here, we can notice that we have 3 new hub locations on top of our existing one for a total of 4 hubs. And that allows us to deliver to all of our customers. And this is great. However, if we take a look at the data here down in our attribute table, we can see that our original hub in Sorrel Tracy is required to deliver to 494 of our 540 customers. And this is just not going to be possible with the current size of the warehouse in Sorrel Tracy. So I'm going to pass this off to Arif here to see if he can come up with a better solution.
Thanks, Brendan. I certainly hope we can come up with a better solution, or this is going to be a short webinar, isn't it? Okay, so we got our 4 hubs, and obviously we can't make that because we have way too much demand on one of them. We want to try to spread that out a little bit. So we're going to try to use a different optimization type. So we're using the same tool, the location allocation tool, but under type, rather than choosing minimize facilities, I'm going to get rid of that option to minimize facilities. So it's the same thing. It's called maximize coverage without the constraint to minimize the facilities. So if I click on that, suddenly I have this little box open up that gives me the ability to define how many facilities I want to assign to this problem. We know 4 isn't enough because obviously it's putting too much weight on our home hub in Sorrel Tracy. So I'm going to up this to 6, and we're going to try to run this with 6 and see what the results are. So let me go ahead and run that with my facilities at 6. Now you can see the destinations being processed. It's going to churn away for just a few seconds. And there we are. So I hope we saw that the solution changed on the screen. Our limes are coming out of different locations, and we have 6 locations now selected. You can see that by the 5 stars and our 1 required hub right in the center. Let me open up our table at the bottom here. We can see that our demand count has shifted a little bit, but what's this? Take a look at this. So we've moved our heavy center from Sorrel Tracy to Laval, and Laval still has a very high demand count, which means that it's serving 349 customers out of that 1 location, which actually is still too high. So 6 isn't enough, and perhaps I could up the facilities a little bit to give it some more room, but maybe there's a more strategic way to solve this problem. Brandon?
Thanks, Arif. Let me just share my screen. I feel like we're getting closer here, but we still need to change a few things. So let's see what else we can try using our location allocation tool. So like before, let's go back into this type option here and see if maybe there's another type that's going to work better for us. And we see one here called maximize capacitated coverage. So this is going to be the exact same thing as the maximize coverage, but you'll notice we also have this capacity window here, which allows us to set a maximum number of customers that 1 hub can deliver to. And now we've determined that our maximum capacity number is 160. With our current administrative team, the most that we want to handle, most customers we like to handle with 1 hub is going to be 160. So we've got that in here. And now we're going to keep our facilities at 6 to see if this is going to work. So let's give this a run. And while this is running here, take note of where the hubs are currently located, and let's see if any of them change after setting a maximum capacity number. All right, look at that. Wow, a lot of our hubs actually moved, and moved towards our dense urban areas where most of our customers are located. Makes sense, that's great. But if you look to the northeast here, we have a couple customers now that we can't deliver to. So this isn't going to work. 6 facilities is not going to be enough. So let's see now if we can increase this 6 facilities to 7, and maybe 7 will be our magic number. And let's run this again.
So just to talk over you a little bit, Brendan, this is doing a lot of calculations in the back end there, right? Where it's actually creating a origin destination cost matrix for every possible hub location and every possible customer. So out of 14 hubs and 540 customers, that's a lot of combinations, meaning there's a lot of calculations it's doing and warming up the room that we're sitting in right now, because Brendan's computer is just, the fan is just blowing like crazy here.
Thanks for that, Arif. Yeah, it's spinning pretty quick, but still being able to process a lot of this data in a pretty short period of time. Some of the processing power there of ArcGIS Pro. It's pretty great. So, all right, let's see what we've got here. So this is better. We now have 7 facilities, But you can see here there's still a customer or two that we can't reach. So 7 hubs is still not going to be enough. Let's try 8. So come back up here and we'll increase our facilities to 8. And we'll see if that's going to be enough for us.
I think I just heard your computer drop a gear. It's it's spinning faster now.
Just for you guys. Look at that. All right, perfect. Look at that. By the looks of it, we're able to now deliver to all of our customers with a maximum of 160 per hub using 8 facilities, except for this lonely little island over here off to the right. And unless one of our hubs has a speedboat available, I don't think that we're ever going to be able to get to this hub, or to this customer, sorry. So I think for now, we're just going to have to cut our losses there and recognize that we're not going to be able to deliver to that location. So now that we've been able to figure this out, I'm going to pass things back to Arif to take us to the next step.
Thanks, Brendan. So we got an answer for the first part of our question, right? The question was, can we make these deliveries on a daily basis to all of our customers? And with that single exception of that lonely coffee shop on that island, I got to do some research. I'm curious as to what island that is. But whatever island that is, they're not going to get the beautiful glaze that that our business has come up with. It's unfortunate, it really is. But, you know, with that one exception, we are able to deliver to the other 539 customers in Quebec. So we have the can. Now we got to think about the how. And we're going to set our scenario up a little bit, and I'm going to go through some details on how that actually happens. So what we're looking at, of course, is the results of Brandon's analysis, and we can see that we've selected a number of depots where we're going to have our home locations or our hub locations. And of those chosen, you can see the list right here in front of us. It's Laval, Terrebonne, Quebec, Sherbrooke, Val-d'Or, Montjoly, Saint-Georges, and of course, Sorel-Tracy. Forgive my French accent. I know it's terrible. There's another column here which actually gives us a little bit more detail about what these hubs are doing. And we've talked about it before, but it's the demand count. This gives us an indication as to how many customers each hub will be servicing. So if we're going to ask the question or attempt to answer the question of how we're going to do this, this is a critical number here. It tells us how busy each one of these hubs is going to be. And how busy it's going to be is going to tell us how many trucks or how many vehicles we're going to need at that hub. So a simple assumption that I can make right now is say, let's assume that one vehicle will be able to service 10 customers, right? I think that's a fair assumption. It is just an assumption, and we'll see how that assumption is going to be corrected soon. But that's the assumption that I'm going to start with. So if each vehicle can support 10 customers, then what we want to do with these numbers is kind of mentally round up to the nearest 10. So in other words, Laval and Terrebonne have 160 each, which means that I need 16 vehicles at each of those hub locations. Quebec has 93, so I'll need 10 vehicles, rounded up to 100, at that location. Sherbrooke, I'll need 4. 1 at Val-d'Or, 1 vehicle there. Montjoly, I'll need 2, 1 at St. George, and 6 at our Sorel-Tracy home branch. So if we do the math, and I hope I got this right, that gives us a total assumption in terms of our vehicle fleet of 56 vehicles. That's how many vehicles we're going to start with to throw out this problem to see if this can solve it. The other piece of information that I need here is in our customers. So let me open up our customer table, and I'll show you something that is going to be critical to help us figure out an answer. So if we scroll all the way to the right here, you've probably figured out that some of the coffee shops may be perhaps in the urban areas like Quebec City or Montreal, or we're going to have a higher customer volume. They're going to have more throughput than some of our remote customers. And so therefore, the bigger coffee shops are going to need more product from us. And that's what this column is. This is a delivery quantities column, and it's been preset just to give us an indication of how many items or products that that location is going to use. And it varies based on location. You can see it kind of ranging from a few thousand. Some of them are just a few hundred. But I wanted this to be as realistic as possible. The other thing that we have here is a time window start and time window end. We don't want to deliver to these locations outside of their business hours. And so while some of them are open 24 hours, what we did is we just took the whole lot and said that we need to deliver to these locations between the hours of 5 a.m. and 11 p.m. And you notice that my dates are all set to April 23rd. We can run this on any day, but for the purposes of this demo, we've left it at that time. So those are a few critical pieces of information that we need in order to answer the question of how we're going to make these deliveries. The next thing we're going to talk about is, this is a good point to identify that in order to do the how, remember we're talking about a professional fleet organization here, or fleet management here. And most fleet owners will have some type of dispatch tool. The beautiful thing about the ArcGIS suite is that we can connect and integrate to other third-party pieces of software very easily. And so we have the ability to connect to most commercial off-the-shelf, even homegrown for that matter, dispatch tools out there. So the dispatch tool that would be in use at various logistics organizations, it has all the data in terms of how many vehicles we have, the capacity of those vehicles, the drivers, all sorts of other information like, fuel consumption costs, driver pay, all that information. And we're going to need that in order to answer the question of how to do this. Now, we don't have a dispatch tool here. So what we're going to do is we're actually going to use an Excel spreadsheet. Nice and basic, but I think everyone here can relate to that. So we've created an Excel spreadsheet, and I do apologize. It looks really, really, really messy. But nonetheless, I'll walk through what we've done here. And this is a list, and there's a lot of tabs here, and I'm not going to go through all of them, just a couple of key ones. This is a list of the vehicles that we're going to throw at our solver. And so down the list, down the left, you can see that we have a number of vehicles ranging from vehicle 1 all the way up to vehicle, oh, thank God I got that number right, 56. Right? The other thing is that we've assigned a depot to all these vehicles, and the way we've assigned them is based on that assumption I made earlier, right? If you recall, we looked at, whoops, let me go back to here. We looked at Laval and Terrebonne having 16 vehicles each, and for example, Saint-Georges would have 1 vehicle. Well, that's reflected here. So we can see our first vehicle here belongs to Saint-Georges, and it's only 1 vehicle for that depot. And if you scroll down a bit, you'll see the numbers increase. So Longueuil, Terrebonne, oh, sorry, I think we got the names mixed up here, but forgive me. We can see that we've attached other vehicles at different depots, and the count is represented in this Excel spreadsheet. We've also identified that the times that the drivers can start is basically any time of the day. That's why it goes from April 23rd midnight to the end of April 23rd, which is 11:59 that night. So anytime during the day, they can start and end their trips. We also have a capacity column. For fleets that have different types of vehicles on there, this is really useful because some trucks are bigger than others, and you might be able to identify that. But for our fleet, we're using the same truck across it, and each truck can hold 40,000 units. We also have to pay our drivers. If we didn't pay our drivers, that would be a fantastic business model, but we got to pay our drivers. So I put 30 cents a minute for each minute that the driver is going to be on the road. That works out to about $18 an hour. And we also have to pay for our trucks. So that's what this 50 cents per kilometer is, and that would equate to perhaps the fuel and maintenance costs for that vehicle to actually be running. We also have a max total time. Sorry, I skipped over max order count because I set them high. We don't really want to limit our analysis based on that, so ignore that for now. But this is critical. Our max total time is 720 minutes. That's a 12-hour day. We do not want our drivers driving more than 12 hours a day. Now, I can adjust this, of course, by driver, so you can see in our Excel spreadsheet, but I've just left it across the fleet, across the entire fleet at 720 minutes. The other tabs that I've made use of is one called breaks, and without going into too much detail here, all we're doing is we're telling our drivers that for every 240 minutes they drive, they're going to need a 60-minute break. We don't want to work them to the bone. We want to make sure they have some time to rest, eat, recuperate, the human part of actually delivering product. So we got to include the breaks. The other thing that we're going to include as well is this thing called route renewals. And the reason I put this in here is since our vehicles have a capacity of 40,000 units, it's conceivable that a truck fills its load, goes out, delivers its load, and then at the end of its trip, still has time left over in the day to go pick up more stuff. And so what this route renewals tab does is it instructs the solver that we're allowing the vehicle to come back to the depot, spend 10 minutes, that's what this number is, filling up with more product and then going out on the road again. So we're giving our trucks the ability to renew their route or refill their capacities and head out on the road. There is countless other variables, knobs, dials that we can tweak in this tool, and you know, we can spend a whole week actually going over a course on this, and we're not going to get into that much detail. So I kept things fairly simple for the time being just to show you how this tool works. We took this Excel spreadsheet and we imported it into ArcGIS Pro. Now, like I said before, in a production environment, this would have been done in the back end with an integration piece that connected directly to your dispatch tool, so you don't actually have to do any import. But also, like I said before, we don't have one of those handy here. So we did an import, and now you can see some of those tables here. There's the assets, breaks, and the renewal table. The other thing that we need to do is we actually need to run the solve. And if you open up the analysis tab for Network Analyst, you're going to see a few options here, and we certainly didn't cover all of them, but what we're looking for is a multi-vehicle route solver. And, well, it doesn't exist here. So, you know what, I'm going to scratch my head on this. I really don't know why it doesn't exist in this drop-down. Perhaps it should, but the way Esri in its infinite wisdom has decided to do, they include it elsewhere. So it's not available here, but if you go to the Geoprocessing tab and actually do a quick search for something called VRP, you will see this thing called Solve Vehicle Routing Problem show up. Click on that, and you know, perhaps this is why it doesn't show up in that drop-down. It is a highly sophisticated tool. There are tons of fields, variables, settings that you can do to this, and it's, you know, you can spend, like I said, a day or a week learning how to use this. So it's very sophisticated. But in a production environment, I'll say it again, most users won't have to fill this in. It'll be plugged directly into your dispatch tool to make it transparent. But for our purposes, we did fill it in. So we connected it with the tables that we imported. We ran the solve. The solve on my machine, which again is just a, you know, a laptop here, an i7, took about 2 minutes to run. And the result of the solve looks like this, right? Every single vehicle that we gave it, it did an analysis to see where it will be able to go, and it populated not only a route with directions, as you can see with the colored lines here, but it also put in a sequence number at every stop along that route. So it tells us where that vehicle needs to go and when. It did this by trying to minimize the costs. So our solver, what it wants to do, although I gave it 56 vehicles, it doesn't use all of them. It wants to minimize the costs associated with this analysis. That's the beauty of that solver. So you remember, if you remember, I put in some values in terms of how much we're paying our drivers and how much it costs to run the vehicles. So it tries to calculate all of that across the entire fleet and minimize it. And that's what you're seeing here. You're seeing the results here. Now, I could very certainly investigate these results here in front of us, or what we can do is we can use this handy-dandy share tool here, share web map. And I did this earlier, so it's already available for us to do. But what I did is I shared this map with the ArcGIS Online organization. Not only do we expand the reach of what I've done so other people can actually start interacting with it, but the real reason I did it is so that I can create, use the web app builder to create some widgets, and we'll walk you through them in a second, to make it really easy to investigate all this data that we see in front of us. And to go through that, Brandon, it's all yours.
Thanks, Arif. Wow, that was incredible. All right, so let me just share my screen with you guys here. So like Arif mentioned, he shared the results there to ArcGIS Online, and using Web App Builder was able to include some widgets here to help analyze the data a step further. So I'll just take you over a couple of the widgets here in the bottom. So first one here, we have a filter. So you can choose between a depot or a vehicle, and you can set this filter if you just want to kind of focus in on one area or one route or one vehicle, so you can really just get some in-close analysis. So for this specific depot, you can see here that it's delivering to 7 customers. We're only using 1 vehicle. And over here, there's some vehicle statistics for the total cost, the total time, and the total distance that that vehicle has traveled. So this can be done for all the depots as well as all the vehicles. So let's take a look at one of the vehicles here really quick. Let's pick this guy. Awesome. So we can see that this one vehicle visits 21 locations. And again, there's more cost information over here about the time and the distance that that one vehicle is traveling. So as well as being able to do some filter information here, you can also click on each individual stop, and it should bring up some information about this stop here. So we can see that the delivery units, there was 1,650 units delivered. It gives us the vehicle and the depot information here. It tells us what sequence stops. This was stop number 18 on his trip. The amount of time it took to get to this location from the previous one, the kilometers traveled, and both the arrival and the depart time. So this is really great. You can see when the vehicles are going to be there and where they're supposed to be going. So as well as the stop information, if you click on one of the routes, you also get a bunch of valuable information here. So you can see again in the route how many orders, the total cost of that entire route, the regular cost here. So this is the cost of our driver. We haven't included overtime cost in this yet just because we didn't need to necessarily get to there, but there's certainly the option for that. And then our distance cost, so the cost of the operation of the vehicle, the total time of the entire trip, 600 minutes, and then even a breakdown between the amount of time he actually spent delivering and then the amount of time that he took for a break over his trip. And then just some more total statistics for the total travel time, the total distance. It's really, really great, and it's nice to see in a really good visual interface here. So, but one thing you may have noticed is that over here, there are two stops that seem like we couldn't make those deliveries. So what happened? During our location allocation analysis, it indicated that we can reach these locations, but once we started putting some parameters and we included our capacity and our vehicles and all of that type of information, somehow, for some reason, we couldn't make these stops. So if we come over here and we click on one of these, let's see what kind of information this gives us. All right. So this tells us that our max total time was exceeded, as well as our max total break time was exceeded. So what happened here? Why couldn't we make these stops? Well, part of it was based, as I've said before, on the assumption that one vehicle can make 10 stops. So for this particular location, we allocated 2 vehicles, and those 2 vehicles weren't able to make it to these 2 locations in time. That doesn't mean we necessarily can't make these deliveries. That just means we might need to make some changes to our route to allot some additional vehicles to this hub. So perhaps if through some cost analysis, we can try and figure out if this makes fiscal sense to try and reach these locations. Otherwise, they might be in the same boat as this lonely island, and we may not be able to get to them if it doesn't make sense. So this is really great. I love using this web app builder. There's some really cool tools. There's a lot more widgets available that we didn't utilize today. But if you have some time to dig around in there, there's really, really some powerful stuff. But perhaps the coolest part, I'm going to be a nice guy. I'm going to pass this off to Arif to show you guys what he's got.
Oh my gosh, talk about setting the stage there, eh? Okay, so we're going to see if this works. Now, we've tested this, and it worked last time, but you know the way live demos are, right? Something always fails to work. So I'm going to hope this works, and I hope, yes, it looks like it's working. So what you're looking at right now is my phone. Forgive the games. I have a 6-year-old daughter that, you know, likes to play some games on this thing. What am I trying to do? Okay, so I want to open up a web browser. So I have it pre-cooked here already. So this is a web browser. There it is. Okay, so it's shown up. Just a standard web browser, and I've already gone to the URL to that same web app that Brandon was looking at on his PC. So why am I looking at this on my phone? Well, perhaps we need a way to disseminate that same information to the drivers who aren't driving around with a PC. They may have an iPhone like I have over here. So it's the same web app, nothing special, but it allows me to look at the same information that you saw on the oh, it's not updating. Give me a second here. We're trying to... Oh, it is updating. Okay, it's just a little slow, so we apologize about that, but it is updating. So I'm looking at the exact same app that Brandon was looking at, but it's on my phone. So as a driver, I might want to have access to this to be able to see what it is. But obviously, you're looking at this thing, and it's quite messy, right? Let me filter this down to just me. Let's say I am driver of vehicle number 5. So I'm going to make sure I'm looking at just my route here. There it is. So this is my route, and I'm going to zoom in a little bit on my route so I can see exactly what's upcoming. So the same information that Brandon was looking at earlier, I also have the the ability to look at here. So I can look at a click on a stop, right? Take a look at some details about that stop as to when I'm supposed to be there, how many units I'm supposed to deliver. But hey, look right at the bottom of this, and I'm waiting for it to show up on the screen because it doesn't seem to be doing so. Maybe not yet. Okay, we're waiting. Okay, see, it I said before that it's never a live demonstration until something actually doesn't work. Oh, there it is. Okay, wow, that was really slow. So nonetheless, you got it. So I got the detail in front of me, same detail I was looking at, but now I'm looking at it on my phone. But take a look at the little bottom thing there. It says navigate, and I got a little Waze icon. So as a driver, it might be nice to just, look at the overview map, look at the information as to when I'm supposed to be there or not. But I might also want to launch my own personal travel companion. I personally use Waze a lot. But if I'm just going to click that Waze button there, I know it's very slow, so I do apologize about that. But hopefully, did you hear my phone kind of say we're all set, drive safely? So it's trying to connect and it's trying to show it. Oh, this is terrible. It's showing up on my phone, but it's not showing up on the screen. We'll give it a second. It takes a little while, I presume. See, I'm going to blame this on you, Brandon, because you set the stage too big, right?
Oh, that's not fair.
You said, look at this, Irish got something awesome here. and I wish everyone was in the room right now because this should be showing to you, but it obviously is not showing. Oh, man. Okay, let me try. I'm going to try something here, okay, just because I really want to show this here. I'm going to try to actually stop sharing. Okay, and then I'm going to reconnect, so just bear with me. I think we got enough time to do this, so just bear with me here, and let's reconnect to my WebEx, and hopefully this would trigger this thing to actually work. No? Okay, let's try one more thing, guys. Bear with me. All right, let's try sharing my phone again. All right, let's give this a go. If this doesn't work, then we'll resort to something else. But okay. Do we see it? We don't see it. No. Okay, we might have to resort to the online. I'm trying one last thing. One last thing. No go. Okay, let's not waste any more time, folks. We'll just get right back to it. I apologize about that. This really was cool, I have to admit. And you know what I might try to do is I might try to re-record it another time, and hopefully, if I can just get my screen shared with my phone, my PC will be able to show something else. What I'll try to do, folks, is I'll try to re-record this and send it off to all the attendees so I can see what happened. But you might want to imagine, you can probably figure out what was going to happen, is when I click that little Waze icon, what really ends up happening is I'll just go quickly on the online version. It's not going to look nearly as cool. But when you click that Waze button, it actually launches Waze on your phone, and if you have it, and it would actually automatically route to that location. And you can see this is the location I'm running now in Waze. As a driver, you would have seen it. Now, on the phone, it would actually routed me and giving me the directions, and if you've used Waze before, then you would know exactly how that works. So I do apologize I wasn't able to show you that. We built it up too much, Brandon. That's what we did. We built it up way too much. All right, back to Brandon. He's got a few things to show you.
Yeah, that's unfortunate. But for you guys who are familiar with Waze, I'm sure you can imagine what that looks like. But either way, a very cool feature nonetheless. And I'm sure when you run it yourself and you're not trying to stream it over the internet over a WebEx, I'm sure it'll work great for you guys. So if you ever get that opportunity, I'm sure that'll work. Okay, so now that we've kind of figured everything out, and now that we kind of know our routes and we know what's happening, let's kind of look at just some overall statistics and just do some kind of comparisons with some of the data that we have here. So I'm looking at a couple of charts here that we've created. And this first one here is a comparison of the total time compared to the total distance of each vehicle that's traveling. So just have a look here. You can see, let's pick vehicle 17. We can see that it's traveling for a very long time. It's out there almost all day, but it doesn't really go very far. So let's have a look at kind of the route that it's traveling here. And as you can see, it's very cool interaction. When I click on this area in the chart, it highlights the route on the map, which is very neat. So let's come zoom in here and see what this route looks like. As you could have guessed, a very, very dense urban area and a lot of stops. Oh, I apologize. Oh, I didn't share my screen. Okay, let's go back for a second here. I think we've got a minute. All right, so can you guys get see that now? Now I'm sharing? Perfect. All right. So as I said, there's the chart here at the bottom. And we're looking at this route here. So you can see that it's out delivering all day, but it doesn't have to travel very far because a lot of its locations are really close to each other. So that's great. That's a nice optimal route. That one there is likely very cost effective. We'll get to that one in a minute. Let's have another quick look at another vehicle route here. So this one here, vehicle 4. It's also traveling for a considerable amount of time, but also traveling a great distance. So let's have a look at this route and see where this one might be. Ah, there we go, as I could have guessed. One of our more rural routes. And as you can see, it looks like it's really only making one stop, but it's has to travel a great deal of ways to make that stop. So it's just good information here that we can see. Let's see what other kind of charts we've got. All right, so this one here is just a basic order count. So this is how many orders each vehicle is delivering to. Pretty simple, but just nice to see. And let's see what else we have here. So this one here is just a total cost. So this is how much each vehicle is going to cost for its delivery route. And it's just nice to see for potential optimization and to see where we might be able to save a little bit of money. And then lastly, this is the big one here, is a combination of the last two. So this is a relationship between the number of orders that each vehicle is delivering and the total cost to make those deliveries. So you can see this pink line here is our average. And as you can see, we've got a downward trend, meaning that the more deliveries that it's making is essentially more cost effective. So this is just good to see. Again, like we still have this one highlighted here, our one truck that's making its one trip. One of our more expensive routes, not very cost effective. So it's nice to see if maybe there's some areas for improvement. And now just for one last more summary for some statistics, I'm going to throw it back to Arif.
Thanks, Brandon. All right, share my screen one last time. Here we go. So now I'm going to look at just the overall statistics for this entire fleet optimization that we've done. Brandon's walked through a couple of the charts to show you how we can compare different routes and highlight some of the ones that are outliers. But at the bottom here, what I've done is, it doesn't look nearly as pretty, but it does give me the overall statistics for my entire solution here. So what I've done here is for 30 drivers, that's what this frequency number tells you at the bottom, we have a mean order count. So the average order count is just about 18. Minimum stop time, you don't actually see it, or minimum start time means that this is the earliest time a driver leaves its depot. Since we don't see a time, we know that that's midnight. So the earliest time a driver is leaving the depot is at midnight. Average time is 4 o'clock in the morning, so most of our drivers are leaving at about 4. Maximum end time is our last driver returning back to the depot is just before 5 o'clock in the afternoon. Most of our drivers are coming back at about 2:30 in the afternoon to the depot. Our total distance, our mean total distance, means the average distance a driver is driving is about 300 kilometers per day. The total distance is just about over 9,000 kilometers for the entire fleet. We have a mean total time of 630, so 630 minutes average we're working our drivers. That is high, but this is good because it gives us the indication that, you know what, maybe we can throw some more vehicles at this, or even lower that, that maximum time, or lower the order count in order to kind of weigh that out. But this is a fantastic indicator telling us how hard we're working our drivers. Our total minutes across the fleet are about 18, so roughly 19,000 minutes across the entire fleet. We have a cost here, an average cost of $340. This cost is accumulation of what we're paying our driver plus the actual cost to run the vehicle. So it costs us $340 per vehicle for this solve to work. Now, obviously, that doesn't include the cost of purchasing the vehicle, just the operation of that vehicle. So that's $340 a day, and right at the end here, we have our total cost of $10,200. It is costing us $10,000 a day to make this optimization happen. I think we have the answers we're looking for. We asked ourselves, can we make these deliveries across the province on a daily basis? How are we going to be able to deliver that, and how much is it going to cost us? We've answered the can. We certainly can do it, minus of course, our island location here. We now have a fleet and sequence number, 30 fleets, and a given sequence for each and every one of our trucks to make those deliveries. We know how we're going to deploy it, and we know it's going to cost us $10,000 a day to make this happen. I think that's a pretty good success, don't you?
I'd say so.
Fantastic. All right, folks, we're going to try this one more time just because I really want this to work. So if we could share my screen with my phone, and I'm just going to give it one. Okay, you know what? It's not going to happen. So that's fine. Let me just go back to our slides for a moment, and I'm going to wrap this up. We do have a few questions that I want to get through as well, so hopefully we'll be able to get to some of these questions in the few minutes that we have left. All right, fantastic. Thank you very much, Ian. All right, so there are some related training courses. Just as we're wrapping up, if you did want to touch on some of these things, migrating from ArcMap to ArcGIS Pro, creating optimized routes using ArcGIS Pro, and of course creating origin destination cost matrix in ArcGIS Pro. You'll receive these links following this webinar, so you'll know exactly how to get to those locations. And of course, the recording and hopefully the augmented recording, including my little Waze link, should be included, and we'll make sure to get that off to you. My fingers crossed that we're actually going to get there. And of course, if you have additional questions, here are our email addresses. I don't think we're going to get through all of our questions, but we will certainly go and try to get through as many of them as we can right now, okay? So the first question you have here is, can this be done using real-time traffic conditions? The answer is an astounding yes. Of course it can be. So if I can share my screen quickly there, Ian, I'm just going to, there we go. Sorry, my screen. Okay, so on any of these layers, if I actually open up this layer that we haven't actually showed before, but it's called this routing ND layer here, and it takes a minute to show up because this is actually all of the traffic across the entire world, really. So there it is. You can see it coming in on the left here. Those are historical traffic. So the analysis actually takes into consideration the historical traffic trends on every single street in order to figure out what the time is to actually make that trip. So you can see it painting, and it's taking a long time because there's a whole lot of data. The question was, can we link this to live traffic? The answer is yes. I've pointed this to historical traffic today, but we can certainly link this to live traffic in order to get better results or more accurate results. All right, so I need to see where my next question is. So there it is. Okay. Sorry, bear with me. I'm just having some troubles trying to get this up on my screen. Okay, and now the question is, does the delivery daily? Yes, it is. So this is a daily delivery. That's what the optimization was done for. Is there any way to stop the service area rendering right at the borderline? Yes, absolutely. So you're referring to this page right over here. What we've done is that you can see the service area. It does include areas of Canada and the US, so absolutely. I haven't done that, but it's a simple mask that we can assign that limits our service deliveries only to Canadian or even only to Quebec. So that's a very easy fix that we can do and put that in there. All right, we have some questions about truck travel times. Perhaps that might be the difference between truck and driving travel times?
Yes, yeah. So we run the analysis for both the truck driving time and the regular car driving time. And we did notice a few discrepancies. They weren't overly major, but it did make some changes to our routes. So be sure if you're going to run this to indicate to the tool which setting you would prefer. Definitely.
And that happens because, you know, trucks can't go down residential streets. There's certain roads that are exclusive to trucks, not exclusive, but you cannot drive a truck down, so truck routes only. So it takes those into consideration when actually doing the analysis. That's why there was a difference in trucking and driving time. There's a question about the 14 possible hub locations. Where did it come from? The 14 was simply, you know, our guess, really. That's all it was. We have to give the solver something to start with. Brendan, you want to say something?
Exactly, yeah. It was just kind of an assessment of looking at where our customers were located and just choosing locations where the high concentration of customers were. So it was a bit of an assumption, kind of choosing how many vehicles can deliver how many to how many customers. So of course there's going to be a little leeway there, but it was just an assumption, and we wanted to give a large number, 14, knowing that we probably weren't going to need all 14, but we wanted to really make sure the tool did as much optimization to figure out which hubs were the best location.
There was also a question here about, are the route as the crow flies or the best route for the analysis? And the answer is the latter. So this is not as the crow flies. I know when we were doing our location allocation, you saw some straight lines going from the origin to the destination. Although those are just there for visualizations, but the actual calculation is done using the actual road. So this does give turn-by-turn directions for every single analysis done, and it calculates the cost for the actual route taken. So it's visualized this way in this analysis, but it uses the actual distance for driving. There's another question here about defining the capacity in anything other than a customer count in exactly where, for example, warehouse volume. Yes, there is. We definitely can, and in some ways we've already done that. We use the capacity to coverage to indicate what the capacity of each warehouse would be. There are other ways to do that as well. So we've completely skipped over. We didn't include the ability to identify when goods arrive at warehouses. You can actually set up all sorts of analysis to say that a good is not available at a warehouse until a certain time in the day. So we have a lot of control that we just skipped over in terms of warehouse management here. So yes, I'm sure we can engage in a conversation after the fact. I'm happy to do that. Both myself and Brandon are available to engage in that conversation. Are the analysis tools shown here in ArcGIS Pro available in ArcMap? I apologize, it did not mention when I started that yes, they are. So these are also available in ArcMap. And so yes, we can do that. And in order to get the network analyst license, you can do that either in Pro or ArcMap. Just talk to your sales rep and we'll make sure we get there. We do have a few other questions. However, I can see that we're at 2 o'clock, so I think we have to call it close right now. For those questions that are still on the list, myself or Brandon will reach out and we'll definitely get those questions answered for you. If you have any further questions, please do reach out to us and we'll make sure to get those questions answered as well. All right, but I think that pretty much wraps up our presentation, so thank you all for joining today. I wish we had more time to go over all this material, but like I said, again, we're happy to answer questions offline as well, so please reach out and we'll make sure to connect. Any final words, Brandon?
I just want to thank everyone for coming out today. I hope you learned a little something, and just great to see the power of ArcGIS Pro.
Thanks very much. Have a great day, folks. Take care.